Okay, last question. You've got a curve which is y equals f of x, or y or f of x, whatever you want to call it. It's already been differentiated, and what we need to do is find, the stationary points has already been found, and what we need to do is just say what the nature of the stationary points is. The nature means a maximum or a minimum or a point of inflection. Now you should know that the only way that you could determine whether it was a maximum or a minimum is by d squared y by dx squared. So what we need to do is differentiate this. Now we can't differentiate it while it is in the bracket, so we need to get rid of the bracket. So we square out that bracket, you get x squared minus 4x plus 4. Get rid of the big bracket, so you get minus x cubed minus 4 plus 4x squared, so beg your pardon, minus 4x. So that is dy by dx. So what we need to do now is differentiate it again. So minus x cubed becomes minus 3x squared plus 8x minus 4. Now that is the second differential. So all we've got to do is put our stationary points through. So if you start with the first stationary point, which is that should tell you that x is 0. So all you've got to do is substitute into d squared y by dx squared, which is minus 3 times 0 is 0, plus 8 times 0 is 0, minus 4, which is minus 4. Now because that is less than 0, so d squared y by dx squared is less than 0, that means it is a maximum. And then you've got to do the second point. The second point is 2, 0, so it's the same thing. You substitute into d squared y by dx squared, and you get 2 squared is 4, times it by 3 is minus 12, plus 8 times 2 is 16, minus 4 is 0, which means it's neither positive or negative. It's equal to 0, so it is a point of inflection.